Differential equations, 2001, question 10a. So this is type 1 first order differential equations. And the first part of the question says find d of dx of y of x. So basically what that means, d dx of y of x, means find the derivative of y over x. So if we're finding the derivative of y over x, well, it's quotient rule because we have u over v. And therefore we would say the derivative of y over x is equal to v times du dx minus u times dv dx all over v squared. And again, we can find that on page 25 in our tables. So therefore, if I sub in for v and u here, well, the derivative of y over x is v is x times du dx. So if I differentiate y with respect to x, I get dy dx minus u, which is y, times dv dx. So if I differentiate x, I get 1 over v squared. Well, that's going to be over x squared. And then if I simplify that, the derivative of y over x, well, x goes into x squared once, so that would be 1 over x dy dx minus y over x squared and if we look, that says hence or otherwise solve this differential equation. So there was 5 marks for finding the derivative. And the hence or otherwise, well, the hence means we've just found the derivative of y over x. Otherwise, we could find another way of doing it. So let's write out what we have. So we know that the left-hand side there is the derivative of y over x, and that's equal to 1 over x. So if we integrate both sides, so in other words, I multiply both sides across by dx there. Well, if we're looking at the derivative of y over x, the antiderivative would just be y over x. And the antiderivative of 1 over x, well, that's natural log of x. So in other words, we've just found our antiderivative or integration. And of course, we need our limits because otherwise we have to put in plus c. So at the start, we know that x is 1 when y is 1. And at the end, it's just going to be in terms of x and y. So therefore, my limits here would be my upper limits being the end limits. So we'd have 1. Sorry, actually, if we're doing antiderivative, we'll be using our c. So we have y over x is equal to 1 over x plus c. But we know that when x is 1, y is 1. Sorry, we have our antiderivative of that is y over x, and our antiderivative of 1 over x is natural log of x plus c. And then we know when x is 1, y is 1. So that should be natural log of 1 is equal to c. And of course, natural log of 1 is 0. And therefore, that gives me c is equal to 1. So therefore, I can say that y over x is equal to natural log of x plus 1. And therefore, y is equal to x times natural log of x plus 1. So a slightly different take on our first order differentials there, using our antiderivative approach. So we only had 15 marks going for that. So we had 5, and then we had 5, and then we had 5 for the start.